Hello, everyone. This is the other part for making the lake plot for the Oregon Spotted the Frog series. So this is as you can see, this is the map that we are going to make with a studio, and we are going to use the leaflet package for making it. So as you can see in the final version of the map, you can see that there are some frogs. They are two different colors, and then we have these circles here that we will see how to build them up and what are they exactly. But I can anticipate that they are the range of frequency, the average range of frequency for some for the frogs that haven't been visualized. Okay, and then we add a few other features in the map, and so let's get started and see how to make this lake map. Okay, so here I've set a new R script named lake map screencast.r, and I've saved it for the minute inside the scripts folder in the container inside the frog in my GitHub repo. So I've shown this on a previous video. And so inside the scripts, there's some scripts for making all the pieces of the plot inside the main visualization. So this is the lake map screencast R, and this is the lake map. So the one it's already being made, and you can find it in the repository. Okay, so the first thing, we need to load the data, load the tidyverse library, because this it's a meta package, so there's few other packages inside, and I found this straightforward to load tidyverse instead of the single packages. So we load tidyverse, and then we load the Oregon frogs dataset, which is now a package. And I'll make a further screencast about how to make a package with just a dataset inside. But for now, we still load it from the GitHub, or otherwise we can even try. We can even see how to, because I've already installed the package from GitHub. So if I do Oregon frogs. Okay, let's stick with the plants, and then we go back on these things. I don't know why these things are. But anyway, so this is the frogs data set, and we know that already how it is. So it's made of the main site where the frogs are located, the subsite, the habitat, the survey date, the ordinal numbers of the years, the frequency, the geolocation, which are the two vectors we are interested in today. Then there is the interval. Other variables are the sex, the water type, the structure, substrate, beaver, if there's any beavers, and the detection. So the next step for our visualization is to basically transform these two vectors, which are, what are they? So this UTME83 and this UTMN83 are the geolocation and exactly the distance in meters from the equator, and the distance in meters from the north pole side. So these are to locate the frogs, okay, where the frogs are located. So we now need the latitude and longitude for format of these geolocations. So we are going to change these things from spatial and data to a simple feature data. Okay, so what we do is to first things make a table of the longitude, because this equator will be the longitude, and the future latitude, which is this one here with from the north. So we make a table, and what we obtain is the same thing as before, just we now they are on a table. Then we go forward and we see what's happened after we do make the Myers change. So this is what we are going to do. So we use this package simple features so that you can load it doing library simple features, okay, and you load it. And as you can see, it links to Geo and other packages, GDAL, and so to work on spatial data. And we use this function from simple features package, which is this one here. And it's nice, good start to understanding how to deal with spatial data. Oops. So this function basically converts a foreign object to a simple feature object. Okay, so what it does is basically take spatial data such as meters, distance they are, and transforming as simple features. So we need to specify inside the function that we want to use this data here that we have just made in a table, and then the chords are those one in the first two columns, and then we specify the location. So this is basically to like the inclination of the earth or something like that. So you specify to your transformation function what is the perspective view that you are going to start with, and then you assign the values to transform them in as simple features. Okay, if we do what's happened just using this function, okay, we see that they are now a geometry. Okay, as you can see inside the geometry, so this is the skeleton of a simple feature, which is a geometry. And now he said that they are in meters and are in this format. So it automatically transform your data into this XY dimension. It's considering a bounding box from its minimum longitude and minimum latitude, and maximum longitude and maximum latitude. The location starting point is this one here, so it's a UTM reference in zone 10. But now we can still not use them as is, as they appear with this first transformation. We need to transform them now. So in a way that we have a long lat, so longitude and latitude, and again they are located with this specification, and we can see what's happening if we use ST transform. Now they are a bit more like familiar numbers, or as they should be. So now they are longitude and latitude by grade. So you can see that now you can use them, because with this function here, what we do is to transform again these coordinates from simple features, okay, to latitude and longitude. What I to have a look at is this target coordinates reference system. So it is an object of class CRS, and you can search on the internet and you find how to add this bit here, or change it if you like it. For now, we go forward making the visualization, and in case we go back to this thing here to expand a bit more. In the meantime, we can even see that you can, like, for example, provide these options, and this is for making like sure that you are locating and assigning values to correct locations, basically. Okay, so now this is so what we did is transforming like spatial data as they are to a simple feature, and as you see, we obtained a geometry in meters, but we still couldn't use it. So then we can transform them into a spatial data. So now it is still a simple feature, but we now have longitude and latitude. So find this option again with proj long lat instead of proj UTM. We now have a geometry with longitude and latitude. Okay, as you can see. We assign them to be in a T-bone as before. So now we have this frog chord, which is now a geometry, but it is a T-bone and not a few simple feature. Okay. We have this column, which can be assembled to other data in a T-bone. Okay. What we do now is assembling the other parts of the. So, how can we like call this spatial data related to our informations? So now to this frog chords, will be used here as along with other information from the frogs dataset, like the detection, the subsite, and the frequency. Now, to have two clear vectors, which are latitude and longitude, what we do is mapping our frog cohorts, T-ball, this one here, selecting like the first element and the second element, which is 1. The second element is the latitude, and the first element is the longitude in a geometry. So mapping this bit here, we obtain some like the elements inside the geometry vector for the latitude as a list. So we now need to unlist them. And so we have a vector. The same we do for the longitude, so the other things, and we put them all inside a table. So now we have a nice table with all the information that we need for making a map. So we have the detection, because we are interested. What we want to do is to like visualize the frogs which are captured, not visualized, or visualized in the various subsites, and even have some information about the frequency, and put them where they have been located inside the map. Right. Okay, so now we need a bit of more wrangling, because to finally obtain what we did, it's important to have some extra pieces that we need. So like we need to make this frog captured. So we need to select from this from our table, okay, filter just the one that those ones that have been captured. Okay, so we do filter detection equals to captured. So in a way that we have our table just for captured frogs, and then we do the same for those ones which are visualized, just visualized, not captured, are those ones here. And then for those ones which are not visualized, we need to again filter them by detection not visualized. Then we group them by subsite, because as you can see, the subsite can be Southeast Pond, West Reservoir, or Northeast. So there's quite a few locations, and there will be, because we basically, why I do this is because for those little circles that you see in the visualization, I have plotted this the range of the frequencies just for those frogs that are not visualized. So for the frogs that are not visualized, we don't have the icons with the little frogs. We have just the circle for the frequencies. So I make sure to have the all necessary information this way. So after having filtered them, I group them by subsite, and then what I do is round the frequency by the differences, from the maximum value to the minimum value. I could have done the mean, rounding the mean average, the mean range, but I rather prefer to do this in a way that I have the location which is centered this way. Okay, so then I rounded and then adjusted because otherwise the circles were too small. So in proportion they are all the same, but this way you can visualize them like clearly, a bit more clearly. Okay. So we will go back to that a bit later. So now this is the new table for not visualized frogs, and we have this range. Okay, mind that this is multiplied by 50 because otherwise the range was very like a tiny range, so quite difficult to identify where they were. Okay, that other way you had just a little dot. Okay, so what we do now is add another little pieces of information that we use inside our map. Okay. So this one is the frog subside. How do we make this frog subside, and why do we use that? Okay, now this is, again, we start from the frog location. We group. Now we are not making any selection of the detection condition of the frogs. We just group them by subside, and then now we summarize the latitude and longitude by the mean range. Okay, so now we can name with this information. Then we have the name of the subside location in the map. So we know that the cow camp pond is within in this location, and as well as the Nord Reservoir, and so on and so forth. So now I think this the pieces of information that we need for making our map, it's almost done. Besides the fact that we need a little bit of extra adjustment on about the exact location, and I think I'm not going through this now because this is an adjustment for the the text label I've added in the map. So for centering better, so you can to read a little bit better. So I run this and basically the information will be adjusted about the location. They will be adjusted a bit, so in a way that they can be readable in the map. Okay, so now all the pieces that we need to plot the map are done. Okay, so now we can make our map. So here are some extra information that you might need for making the map. Have an idea how to make the map, or extra documentation about leaflet package, and the logo I've used, the little frogs I used in the map, and then where the data from, and then even the bounding box that you can find in the main page. Okay, I'm not going through them now because we are going straight to make this map. Okay, so we have some two little frogs that we add as a logo. So we have this the frog captured and the frog visualized, and they are a little different. Are with a little different color. Then they are inside the images folder, and one is this and one is the other. So let's see if I can like show them. We can see them directly as we added the map, and so we use the library leaflet, which is quite handling and useful. So I load the library, and then just for curiosity, I show you something about leaflet. As you can see, how can I start about using leaflet? Leaflet is quite straightforward, okay? But somehow, if you want to make modification, add features and things, can be like challenging somehow. But if I go at the bottom of this page, the documentation of the package, there is an index link. If I click on the link, there are some more informations about the package, and then like the version and all the things that you can like, where you can extrapolate extra informations. What else? I can show you here. This is the package version. Here you can find like some examples. And if I do like the same with you can see that you have other extra information like the location, the dependency, the map, and so on and so forth. So basically, you can like work it out. Okay, but just from a simple starting point, such as a simple example. Simple example, you can like make a simple leaflet with leaflet add tiles, for example, and then setting the view, and so it's quite I said one of my favorite packages for making spatial analysis, to be honest with you. Okay, so let's add the pieces for our map this way. Okay. Okay. First part is, so we use the leaflet function, and we set some options. And this is a customization that you do back and forward, making your map. So let's say that the options. Okay, so we can even use just leaflet and add tiles, and then add things, and then we go back adding this zooming information that would be very useful for centering the map in your favorite location. So what we do now is adding bounds. As I said here, the website where the data are from provides a bounding box. Okay, this is the bounding box that you find on the website. So if I add this information here inside the fit bounds function, okay, so I know you can see that maybe I know where I'm going to add my data informations. You can see. Okay, so now my map is centered on my Crane Reservoir in my lake, and I'm going to add my information. Okay, so the extra feature is this. Basically, if I add an option and then leaflet options, and then I add this zoom control false, as you can see, it's not anymore a leaflet, an interactive leaflet. So it's a static map. And this is what I wanted, because for making a static visualization, I needed this to be fixed. So I can do that with zoom control false. And this min and max zoom are the zoom that you might want to set as you like. But basically, this is what suited best for my visualization. So okay, so now we start adding some extra features. And the first that we add is this one here. So we add the circle markers. So the circle markers that we are adding are for the frogs that are not visualized. So are the circles for the longitude and latitude for the frogs that have not visualized. And so we set the longitude and the latitude from our little table, where we modify the frequencies, setting a range, and so we can specify the longitude and latitude, the radius, okay, which is the range, the radius of the circles. So the circle will be of a certain radius, and this is exactly the range that we have established with multiplying by 15 to making like visible. I set some gray color, and here there is like a weight and some opacity that you can, as an extra feature, you can add. See what's happened? So now we have the circles, which are where the frequency is located, the frogs, because they heard them moving and things, but they haven't seen them. So they hide somehow within some location around the lake. So these are a little bit like bigger than the real data, so they are adjusted to be like slightly more visible. Okay, so now what we add are more information. We add some other the markers for where the visualized frogs are. So we use the visualized table with longitude and latitude, and now we add the icon with a little frog, so we can like identify where the visualized frogs are, and they are in these locations. Now the map here cannot be seen, but we see it better later. So you can see that the green frogs are those ones that are visualized, and here there's none. So most probably or are captured or are not visualized. So let's go forward and adding those ones which are captured. Same way, we'll take our little table with captured frogs, long and latitude, and then we add the captured logo. So now you can see they are slightly different color. So those ones are those ones which are then captured, and where are they captured? Okay, so there's still some location where there's none. So they just been heard somehow, they're located, but not visualized and neither captured. So then finally the little the final piece of our map are the labels for the subsite. Like not doing well this thing. Okay, let's do it again. Okay, so this looks like a bit articulated, but actually is not. So we take the oopsie. So we take the subsite longitude and latitude, and we set the label based on the frog subsite table, little table. Which is here, and we have seen that we have the locations, so we then modify to make it visible, and etc. So we use the label option from the add the label only markers. Basically add label on markers, and the label option functions equals to label option to label option function, and so we add some options inside. And this is about the color of the labels, the font family, the font style, the font size, the border colors, and so I've added these things, not hide and text only. This is nice because you don't have the box. So, and what else? Finally, to conclude, what we add is a little map, add the mini map on a side with a specified zoom level offset. And if we do that, there's something gone wrong. Okay. So this is the final. And there's a little map here centered in the location, like zoomed out a bit. And here you can see one of the named locations. Then I show you the others. So as you can see, it's blue and it's like a little bit centered on a position that can be read. Okay, so this is done. Now I'm going to show you again the final visualization. Okay, so as you can see, some frogs are captured, these are the darker, and the other one are visualized. Other are not just being located. And the locations were mostly found within visualized and captured are these co-compounds and river. So here, and even this location identifies like very clear point where they all captured, located, and visualized. Something happened here, I don't know. So anyway, so this is all done. And okay, this is done. So we can go back to our Twitter side and see all the things that we have seen them assembled together. I most probably do another video with how to make the page. And so I see you for the next video. Bye now.